So this is 4.4, part 2. So our trig functions can be positive or negative depending on which quadrant they're in. And different trig functions are positive and negative in different quadrants. So in quadrant 1, all of them are positive. In quadrant 2, just the sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. And the reciprocals that go with them. So sine and cosecant are going to be positive here. And then also tangent and cotangent. And then cosine and secant. A way we can remember this is all students take calculus. The little box says the sentence isn't true anymore, so you may prefer these memory devices: all snakes tease chickens, or a smart trig class. So in example 3, which is our first example today, name the quadrant in which theta lies if cotangent is greater than 0 and sine is less than 0. So this is saying cotangent is negative and sine is positive. So in our quadrants, we have all students take calculus.
The opposite?
You're right. Cotangent is positive, sine is negative. So cotangent is positive where tangent's positive. So that would be in either the A, so our first quadrant, or T, which is our third quadrant. So I can cancel out S and C, because I know it's not going to be there, because cotangent is negative in those. Now this says sine is less than 0, so sine has to be negative. In A, everything is positive, so it's not going to be in quadrant 1. So then the only thing that we're left with is quadrant 3.
And why did you cross out C?
Because C is cosine. So only cosine and its reciprocal are positive in C.
Okay.
So the next one, we're doing the same thing. This is the same problem, right? Yeah. So let's change this to be cotangent is, we'll say, less than 0, and sine is greater than 0. So I just changed the question. So if cotangent's less than 0, cotangent is going to be what? Positive or negative? Negative. And if sine of theta is greater than 0, that means it's positive. So all students take calculus. 1, 2, 3, 4. So which quadrants is cotangent negative? Is it going to be negative in all? 2 and 4. So we can cross out 1 and 3. And then in which one of these two, 2 or 4, is sine positive? 2. So our answer would be 2. Example 4 says, given that cotangent of theta is negative 4/3 and sine is greater than 0, find the following. So we need to figure out what quadrant we're in to find what our R is. Because cotangent's what over what? Adjacent over opposite. So if we have negative 4/3, this is adjacent and this is opposite. But we don't know which one's negative, our adjacent or our opposite, because that negative is just being applied to the whole thing. So cotangent is negative. Sine we know is going to be positive. So let's figure out what quadrant we're in. I'm going to do it bigger down here just so we can see. So I have all students take calculus. 1, 2, 3, 4. So cotangent's not going to be negative in 1. What else can I cross out?
4.
Cotangent.
Sorry.
Cotangent goes with tangent, so I can also cross out 3. And then sine is positive in which one? The second. So I'm dealing with the second quadrant here. So my theta is going to be over here. So I have a little triangle here.
I don't know which way to face the triangle.
It's gonna be like this is in the second quadrant, and your triangle always just drops down to the horizontal axis. Because you wouldn't put it here, because it has to just drop down. So it either drops down or drops up depending on where your line is. Okay, so we have 4 is our adjacent, which adjacent would be down here, and 3 is our opposite. Which one is going to be negative, 4 or 3?
4.
And how did you know that it's 4?
From the x-axis.
Because it's the x-axis and it's in the negative direction, and 3 goes up, so it's positive. And then how can we find r?
Square root of x squared plus y squared.
Awesome. R is equal to the square root of x squared, so negative 4 squared plus 3 squared.
So where the line like ends, is that the point that we're technically like graphing like?
Right here.
Yeah.
Yeah.
Okay.
So that's technically the point. So r is going to be the square root of 16 plus 9. So what's r equal to? 5. It's like our favorite number here. Every example has been a 3, 4, 5 triangle. Is 5 positive or negative?
Positive.
Positive, because r is always positive. So what is our sine of theta? Sine is opposite over adjacent, opposite over hypotenuse, so 3 over 5, perfect. So 3 is our opposite, 5 is our hypotenuse, negative 4 is our adjacent.
Is your R always your hypotenuse?
Yes. R is always going to be the hypotenuse. Cosine would be what?
Or negative 4 over 5?
Negative 4 over 5. Secant is
5 over negative 4.
awesome, 5 over negative 4. And cosecant?
5 over 3.
5 over 3. Perfect.
Is there a reason they don't ask you for tangent or cotangent?
No, what would tangent be?
Um,
It gave us cotangent.
-3/4.
So tangent would be negative 3 over 4. Probably just because all you have to do is flip cotangent, so that's why I didn't ask for it. Next thing we're going to have to find is our reference angles. So the value of the trig functions of angles greater than 90 or less than 0 can be determined from their values at corresponding acute angles called reference angles. So reference angles have to be acute. Let theta be an angle in standard position. Its reference angle is the acute angle. So we use like this theta prime when I'm talking about reference angles, formed by the terminal side of theta and the horizontal axis. So the terminal side of theta and the horizontal axis form our reference angle. We find reference angles to help us find our trig functions, especially when we're not given a unit circle. So that's why we use reference angles. So here are the 3 different formulas on how to find our reference angle. So it depends on which quadrant you're in, depends on what quadrant you're in, will give you which formula to use. So if you're in the second quadrant, you want to use this one. If you have degrees, which 180 is the same thing as pi, so 180 minus theta would give you your reference angle. The third quadrant would be theta minus 180, and then the fourth quadrant would be 360 minus theta. So it depends on which quadrant you're in. Yes.
Last night I was doing.
So if we had all 4, I guess we could say, formulas together. If you're in the first quadrant, your theta prime is going to be the same thing as theta. So this is the first quadrant, second, third, and fourth. If you're in the second quadrant, your theta prime, so your reference angle, is going to be 180 minus theta. Third quadrant, your reference angle is going to be theta minus 180. And the fourth quadrant would be 360 minus theta. And then just know like 180 is the same thing as pi. So here it's the same thing as pi. 360 is 2 pi. So you can always interchange from degrees to radians. So example 4 says find the reference angles for each value of theta. So if theta is 300, what quadrant is that in?
3 or 4.
Quadrant 4. So in quadrant 4, our formula is what? 360 minus theta, which is 300. So 360 minus 300 is 60. So our theta prime is 60 degrees.
You have to just note that theta is prime, no matter.
Yes, you should, just because it's a different theta.
Okay.
All right, for B, is B in degrees or radians? Radians. Even though it doesn't have a pi, it's still radians. So how can we tell what quadrant 2.3 radians is in?
Just greater than 2.
We can convert it to degrees. So how do I convert this to degrees? 180 over pi. So I don't have a calculator on me. What's 2.3 times 180 divided by pi? So let's just say 131. 131.7. So this is degrees. What quadrant would 131.7 degrees be in? Quadrant 2. So in quadrant 2, what's the formula that I have to use? 180 minus 131.7. So what's 180 minus 131.7? 72.3, but 72.3 is in degrees, so I have to convert it back. What you could do instead is, we know that 2.3 is in the second quadrant, 180 is pi, so just do pi minus 2.3. So just convert it to help you tell what quadrant it's in, and then plug it back in like the radians, and use radians here. So what's pi minus 2.3? 1.8 something, right?
Oh, I'm just doing different. Oh, it's 3.1. Yeah,
Logan.
So you have to subtract 131.7 from
0.8. Because it's 3.14. So what is it, 0.8?
Yeah, 0.8.
Something.
Or
Ish.
1.5.
Yes. So this should have been 48. 48 point what?
I was not
0.3.
Wait, which one
And
was 48?
then our reference angle here in degrees would have been 48, and we would just have to convert that back, so we could multiply it by pi over 180, and then that would give us 1.8 something.
Wait, why isn't it 131.7? What do we do with that?
Because this is in degrees, since our question gave us radians, we have to convert it back to radians.
So when we subtract those, we get 48?
So this here is our reference angle. All right, let's look at C.
Wait, our reference angle is 28?
The first thing we want to do is find a positive coterminal angle to this. So how do I find a positive coterminal angle? Add 360. So what do I get? Negative 135 plus 360.
225.
225. So what quadrant would 225 degrees be in? The third. So in the third quadrant, what formula do I use?
Theta minus 180.
Theta minus 180. And theta here is 225. So 225 minus 180.
And you wouldn't get the right answer if you did negative 135 minus 90?
No, because it would just be like a bigger negative number, and your reference angle has to be acute.
So it would be 45?
So you have to get the coterminal.
Yeah, you have to find the coterminal angle. So our reference angle is 45. Yes. Reference angle has to be acute. So how can I tell where 2 pi over 3 is, what quadrant it's in? I can convert it. So 2 pi over 3, how do I convert 2 degrees? 180 over pi, so the pi's cancel, 3 goes into 180 60 times, so this would be 120 degrees. So what quadrant is 120 degrees in? The second one. So 120 degrees would be here. So this angle from the start, the initial side, to the terminal side, this is my theta. 120. Or theta is 2 pi over 3. Which formula am I using in quadrant 2? 180 minus theta, but here I want to stick with radians since it was given to me in radians. So what's pi minus 2 pi over 3? So pi minus 2 pi over 3. What do I need if I'm subtracting fractions? Common denominator. So I'm going to change pi to be 3 pi over 3, which would make this pi over 3. So my reference angle is pi over 3. My reference angle just goes from the horizontal line to the terminal side. So this here would be my reference angle. How can I tell where 23 pi over 6 is? Convert it. So I'm going to multiply it by 180 over pi. Pi's cancel. 6 goes into 180 30 times. So 23 times 30 would be 690, I think.
Yeah.
Yes. So good. Look at me doing that in my head. All right, 690 is more than one trip around the circle, so I can subtract 360 from it to find what a coterminal angle to it. So this would be 330. What quadrant is 330 degrees in?
Oh, wait.
Because I'm going around more than once, so I just want to see how much further I go after I go around more than once. So it would be 330. So that would be in which quadrant? Quadrant 4. Yes. Yes. So if it's in quadrant 4, what do I need to do? What do I do? 2 pi minus theta. So 2 pi minus theta. Theta is 23 pi over 6. So I need a common denominator. I'm going to change this to 12 pi over 6.
How come you can't just subtract 330 minus?
What we can do is use 330 because this is a coterminal angle that's on our circle. It's less than 360, one trip around. And just do 360 minus this. You guys can't see that color. So 360 minus 330, which would give us 30, but we have to convert this back to radians. Since our question was given to us in radians, the answer has to be in radians. So converting 30 back to radians, we multiply it by pi over 180. And what do we get? Pi over 6. Awesome. So pi over 6 is our reference angle, which that would be from our terminal down. So this would be theta prime. So our reference angles from the positive x-axis to our terminal side, whatever it ends up being, that's our angle that's given. That's our theta. Our reference angle is the acute version of it. So if we were asked to find like the sine of theta, we can use our reference angle to help us find the sine of theta because the sine of theta is going to be the same thing as sine of the reference angle, sine of theta prime. But the only difference is that the sine, not like the sine, but like positive or negative, will be different depending on what quadrant it's in. So we are going to use our reference angle, and then we always have to check the sine of all 6 of our trig functions, whether it's positive or negative, by using all students take calculus. So we find our reference angle to help us find the sine of theta, and then we just use all students take calculus to find the sine of that, whether it's positive or negative, for all 6 of our trig functions. So that's why we use reference angles. So that's kind of what the next couple slides explain. So it says sine of theta and sine of theta prime are equal except possibly in the sign. So whether it's positive or negative. So when we evaluate trig functions of any angle, to find the value of a trig function, we have to determine the function value of the associated reference angle. So we find the reference angle first. And then depending on the quadrant that theta lies in, we affix the appropriate sign to the function value. So we determine whether it is positive or negative, depending on what quadrant. So that's where we use our all students take calculus. So find the reference angle, determine the signs.
Sine theta delta is always in, or theta whatever, is always positive, right?
Our reference angle is always positive and acute. So this kind of helps us when we have our reference angle to see what, like if we had sine of 30, that would be 1/2. But you won't be able to use this on the test, so I'll show you how we can find it without this box. So let's look at A.
Says the homework as well.
Okay, so here we're evaluating the trig functions.
After that midterm review?
After that's midterm review. So first thing I want to do is find my reference angle for cosine of 4 pi over 3. How can I find my reference angle of 4 pi over 3? How do I know what quadrant it's in? Change it to degrees. So I'm going to multiply by 180 over pi. So the pi's cancel. 3 goes into 180 60 times, and 4 times 60 is 240. So what quadrant would 240 degrees be in? The third quadrant. So in the third quadrant, I'm going to use my formula theta minus 180, or I can do 4 pi over 3 minus pi, because I'm going to use pi's instead of degrees. Actually, I'm going to keep it in degrees. Again, I'll explain why in a second. I'm going to keep it in degrees. So 240, I'm going to do 240 minus 180. So it's 240 minus 180. So my reference angle here is 60 degrees. So I'm finding the cosine of 60 degrees. So I'm going to make my triangle a little bit bigger here. My reference angle here is 60. So what type of triangle do I have here? 30, 60, 90. Right. So it's part of the whole angle, but if we took the cosine of 240, it's going to be the same thing as the cosine of 60. The only difference is the sign would be different. So like it could be positive or negative depending on which quadrant it falls in.
Okay. So technically it's coterminal, or no? Because like if it's the same type of angle.
It's not coterminal, it's a reference angle, because coterminal would be like the same ending point.
Okay.
So here I have a 30, 60, 90. What do I know is across from 30?
X.
X. What's across from 60? X square root 3. And what's across from 90? 2x. So if I'm finding the cosine of 60, 60 is my theta here. The cosine is what?
Opposite over.
Adjacent over hypotenuse. What's adjacent to 60? X. And what is the hypotenuse? 2x. And how does this simplify? 1/2. It is a lot. So the cosine of 4 pi over 3 is 1/2.
Can you like label the reference angle and the, I don't know, which one's over below like apostrophe?
The reference angle is the
And what's
apostrophe
the
one.
like regular one, the theta?
Yes.
So can you label both of those on this graph because that's what?
So this is our reference angle here.
Correction, Jaden Wallace. Report to Student Services, Jaden Wallace. Support Student Services.
Our actual angle theta is this whole thing.
How do you know
Okay.
60?
Because we had to do theta minus 180 to find the reference angle, because it's in the third quadrant. But what we also have to do is determine the sign of our answer. So it's either going to be positive or negative. So we're going to do all students take calculus. We're finding the cosine. So in the third quadrant, is cosine positive or negative?
A negative.
It's negative because only tangent and cotangent are going to be positive in the third quadrant. So this should be negative 1/2. All right, so next we're going to find the tangent of negative 210. So first thing I want to do is find the coterminal angle to 210, negative 210. So what should I do to find the coterminal angle? Add 360. So this would be 150.
Yes.
What quadrant is 150 degrees in? The second. So it's in the second quadrant. This is 150, so that's my theta. But I want to find the reference angle here, which is going to be theta prime. In the second quadrant, what formula do I have to use to find my reference angle? 180 minus theta, which I'm going to use 150 here. So 180 minus 150 is 30. So theta prime is 30 degrees. I'm going to make my little right triangle. What's across from 30? X. And what's across from 60? X root 3. And then across from 90 is 2x. Here it asks me to find tangent. So tangent would be what over what?
X over X.
It would be x over x square root 3. Opposite over adjacent. So 1 over square root 3.
We have to rationalize.
And we have to rationalize it. So what would it be?
Root 3.
Square root of 3 over 3. Last thing we have to do is check our sign. So all students take calculus. Is tangent positive or negative in the second quadrant?
Negative.
It's negative because only sine and its reciprocal are positive. So this should be negative root 3 over 3. Yes. Yes. All right, so last one is cosecant of 11 pi over 4. How can I tell what quadrant 11 pi over 4 is in?
Convert it into degrees.
Convert it into degrees. So multiply by 180 over pi. Cancel out the pi's. 4 goes into 180 45 times. And 11 times 45 would be 495. 495 is more than one trip around the circle, so I need to find the coterminal angle, so subtract by 360. So this should be 135. And what quadrant is 135 in? The second quadrant. In the second quadrant, how do I find my reference angle?
180.
180 minus 135.
180 minus 135, which I could use radians, but since I'm going to use a 30, 60, 90, or a 45, 45, 90 triangle, I want to keep it in degrees. So 180 minus 135 would be 45. So this is 45 degrees. So I have a 45, 45, 90. So across from 45 is what? X. Across from the other 45 is going to be x, and our hypotenuse is x square root 2. So this tells me I need to find the cosecant. So cosecant's what over what?
Hypotenuse over opposite.
Hypotenuse over opposite. So what's our hypotenuse?
X square root 2.
X square root 2 over
X.
x. So the x's cancel, so this is just square root 2. And what's the last thing I need to do?
I'll make sure it's positive.
Make sure the sign is right. So make sure if it's positive or negative. So all students take calculus. So sine and its reciprocal, cosecant, are positive in the second quadrant, which we are dealing with cosecant, so it is positive. So positive square root 2.
Do we have